All right, everyone, here we go. Rockstar Network Foundations, Chapter 1, Module 1. All right, in this program, these are some of the icons we're going to be using. You might recognize these from some other material out there. Some of them are old, they've been around for a while. Some of them are newer, but these are the icons that we're going to be using throughout most of these courses. So this PC over here could be a workstation or a server, and we will go over more details about what the difference of those two is a little bit in this class. This is going to be our PC icon, our laptop, basically just a computing device. We've got an Ethernet hub there. Now, one thing that's unique about this icon is notice there's one line going across the top, which means it's a layer 1 dumb device, and we'll get into what that is as we go forward. But this icon over here is an Ethernet switch. It's got the two lines going across it, and it's even though it's kind of the same shape, they're two different things, right? So we don't see many hubs around these days anymore. It's kind of an older device, a legacy device, but we'll talk about those nonetheless because it's important stuff to know. Then we've got our router, and you notice the different arrows coming in and out. Routers are, of course, devices that are there to interconnect networks, and we will be talking a lot about that. The next one over here, this little brick-looking guy with the sine waves on it, is an access point, a wireless access point. So you'll be seeing some of those. This is a firewall, so you notice we put the wall in there, and then we also have the magnifying glass for traffic inspection. Okay. The next one is this dotted line here, or the dash line. That's a console cable connection. Again, the sine waves is an RF type of connection media. So down here, these are all different types of connections that you might see used in the topologies. Okay, the straight cable is going to be the Ethernet cable. If you see a straight cable with the X on it, that's an Ethernet crossover cable, and we'll go over the differences of those as we go forward. The jagged line here, that is always going to be indicative of a serial cable. And then finally, you've got the cloud over here, which could be WAN access or internet access, depending on what we're using it for in the topology. So just want to get everybody familiar with these icons as we move forward in this class. All right, so let's answer that first question, okay? What is a network? What is a network anyway? I know it might sound simple to some of you guys, but think about it. A network is a collection of connected devices, okay? And they come in different shapes and sizes. Obviously, the coffee shop, downtown doesn't need as much technology as, a Boeing or GE Capital or some of the other Dell or any of the larger, multinational or global enterprises out there. They might just have a basic network and maybe some guest Wi-Fi for the users. But they're not going to have as elaborate setup as the larger companies. So networks come in all different shapes and sizes. In fact, you might be familiar with setting up your home network, for use at home, and that's just for you and your family and maybe some visitors that come over. Most of that nowadays is, of course, Wi-Fi. If you've been around tech for a while, you might have had a wired, shared network back in the day, but you'd definitely be in the geek, club if that was the case, and that's all good because I had one of those going back a ways, right? Everything started off as wired connectivity, and it was a blast. So anyway, so in the field of networking, and in this world of Cisco, Cisco considers a small to medium-sized network to be 250 connected nodes that are not just computing devices, but routers, switches, access points, firewalls, things like that. Actually, 250 networked nodes. So not in stations like a laptop or a computer, but all the interconnection equipment that goes along with making a network. Okay. So, why networking? Well, in short, we needed a way for multiple devices to be able to communicate across a shared medium. Okay. There was many different choices for networking back in the days, many different types of connections and cables. And, honestly, if you go back far enough, all the vendors that were out there, if you were to buy, let's say, a system, a computing system from IBM, right? You were state of the art and you were using IBM. Well, there would be, you'd buy everything from IBM. You'd buy the servers from them, you'd buy the cables from them. It was IBM cables, it was IBM software, it was IBM everything. Now, if you wanted like a new accounting app that was used from another vendor, well, you were kind of SOL because you bought everything that was IBM, so you were stuck in that IBM ecosystem. We needed a way to be interoperable and share data across a shared communications medium, because that whole proprietary system in the world of computing just wasn't going to work for people and allow innovation to happen, right? And, you know, this is one of those things where there was a lot. That's kind of a loaded thing I'm talking about, to be honest. In short, let's keep it simple for now. We need to be able to share data between two machines, okay? And how that medium connects us is a big part of this course overall. So why networking? To share information digitally, okay? All right, so network topologies. One thing you want to know early on, I know this network may seem overwhelming if you're not used to seeing things like this. If you're one of the students who's going to be brand new to networking and you're seeing something like this right off the bat, don't worry. The big thing that we're wanting to show you right here is that there can be a difference between the way things are physically cabled and the way that traffic moves through the network. So I may have a station over here, for example, that is, you know, we'll just call it computer A, and I'm going to have another computer over here that's computer B. So I've got all these potential paths to take. Which one do I take? Well, you don't know that just because the way something's configured. It may seem like, well, this one goes to this switch, and then I've got a path, you know, that looks like I could take it straight down and get to B. That may work, but that may not be the way that traffic actually flows. It could be numerous options. So this link may not even be in use. It may just be using this link, and then it might still have to go up here, and then it might have to go down this way, and then right back this way. So the point being is, as you're getting to learn networking, just because something is physically cabled in a certain way doesn't mean that's the way that traffic is moving through it logically. So the data is moving throughout the network, right? And that's a big thing to kind of you want to wrap your head around real quick is don't judge a network by its cables. I'm just kidding. And actually, we do judge networks by their cables, because if you get a rat's nest, then it's, you know, it tells you something. But anyway, data, physical network connectivity does not mean that's how data is flowing through that network. All right. So how do we describe a network? If we're going to talk to our peers about networking, what are some of the terminologies that we could use to describe the network to them? Well, we could say we're using a particular topology type, right? We're using like a star topology or a ring topology or a dual ring or a mesh, right? And we'll learn what those are here in a minute. And we could say it's a layer 2 network, it's a layer 3 network, it's a virtual transport network, all that kind of good stuff. Another term we could use is speed. So how fast is the network? We use a gigabit network, or we use a fast Ethernet network, or we're using a brand new super fast 10 gig network, or maybe we're using Wi-Fi and we're using some of that new 802.11ax stuff. So there's a lot of different ways to talk about the network that you're using, and then what to help explain it to your colleagues and coworkers and the community. The other thing is the cost. Everybody comes back to cost at some point, going, oh yeah, we just spent $4 million on this new upgrade. So that doesn't really help explain what you did, right? But it is another way to help describe a network. Security. We have a network that is secure, and we have to meet these compliances, right? So typically whenever we talk about security and maintaining a secure network, it's not just because we want to do that. It's also because we have to make sure that certain regulatory requirements are in place. Quick case in point is like PCI, okay? PCI is payment card industry regulation. So if you take credit cards, you have to maintain people's personal information in a secure manner, okay? And if you don't, you could get fined, and other negative things can happen, of course. So a lot of companies have to abide by these compliances, and that's why they focus on security. Of course, you want to protect personal data, but there's also regulations requiring companies to as well. Another good term to use whenever you're talking about a network is availability. So it's great to say, I've got a zero fail network, right? That means that it's never down. Users can use that network on their devices 100% of the time, okay? But a very common metric, we don't like giving 100 ultimate guarantees, and technology, because something could always happen, right? So a very common metric you'll hear people use is 5 nines reliability or 4 nines reliability. And this sounds really good, right? Like 5 nines, man, that's good uptime. And that's really an industry standard benchmark, by the way. So you're going to hear a lot of people say, yeah, we're 5 nines reliable. Well, what does that really equate to? And we're not going to jump into all that now. Just know that availability is something we'd consider. 5 nines is definitely much better than 4 nines availability. But it still means, let's take, for example, what type of traffic are we sending on the network? Because if we're sending voice packets, for example, 5 nines, even though that's kind of the industry standard, I could still have a lot of dropped calls and fall within that 5 nines reliability, hundreds in fact. But we're not going to jump into that just yet. So these are some of the terminologies we can use to describe computer networks. Okay. All right, so network topologies. This is what I meant by a way to describe a network. Well, a bus topology is, it's not that we don't use bus topologies well, we really don't. We don't use bus topologies anymore. So bus topologies we use whenever I started with computer networks, and we basically had a lot of coaxial cable, okay? And that coaxial cable, you would have stations that kind of crimped into it, and they would all be able to communicate on that bus topology. And with this type of topology, you also had to put these little reflectors on the end of the cable. And the problem with this early topology, though, was the cabling was always messy, but that wasn't really the main problem. The main problem was that if any node failed on these early networks, all nodes would fail. So if one computer had a network card issue, well, that took down the whole thing. So, that's why that wasn't around too long, right? Then we have a ring topology, and this ring is still a common use case actually for fiber rings anyway. But now we have typically a little bit more redundancy built into them than we used to. But the ring topology could kind of fall to that same concept. So back in the day, the early technologies with this had to deal with what's called token ring. Okay, so whenever a station wanted to send data on the network, let's say I had some data to send, okay, and I wanted to put that on the network, well, this token would be coming around to each machine. And whenever it got to my machine, I would add the data to that token, and the token would continue around, and all the other stations would be able to read that data that I just added. So that was token ring technology, and that was, like I said, that was back whenever I started in 96, 95, something like that. That was early stuff. I mean, I really got into networking around 97 and 8, but it was right before that all the token ring stuff was really big. Nowadays, whenever we talk about ring topologies, we're typically talking about fiber networking, which is much faster and much more current technology. So, star topology. This is something we still use today extensively, okay? We use it in switching. Sometimes we use it in routing. We use it in a lot of different ways of networking, okay? It brings us back to where we can have everybody connect back to that center piece of the star. And if we need to scale that out to extend to more areas, we can always do an extended star topology, okay? So, and we use this a lot. In fact, that the previous network we looked at, let's see where that was here, was making use of that extended star topology. Now, they don't always look like those physical shapes, right? But that's what's going on. So if you look, this is a campus access switched design, by the way. And this is that extended star topology, because everything's coming back to these couple nodes, then everything's coming back to these couple nodes. And it gives us the ability to have redundancy and scalability and all that kind of stuff. So we'll talk more about how the star and extended star topologies are working, but these are really your common topologies nowadays, is star, extended star, and then again for ring topologies, typically fiber rings. Okay. All right. So one of the things we want with networking is we want that uptime. We want that redundancy. So one of the ways we can get that redundancy, and wouldn't it just be great if every node had a connection to every other node? Well, you're probably already thinking, man, that just seems like a crazy mess. That would be ridiculous. We've got 50,000 nodes, right? So that would just not make sense at all, right? It would be expensive. Well, whenever we talk about these topologies, guys, and girls, we're talking about not necessarily all devices, but sometimes just routing, right? Or sometimes just switching. So in a full mesh design, though, critical network devices are connected to every other network device. They have a link to every other site. So just think of these as like sites, right? So we could say this is, Austin, for example. This is Chicago. Let's say that this is Oslo. This is, Frankfurt, something like that. And then maybe this is Dallas. So, and then all of these would be corporate locations, right? Well, if we had to have maximum uptime, every device has a connection, every edge router, basically in this case, would have a connection to every other edge router, meaning any point of failure, I still have full connectivity to the other nodes. And actually, there is no real single point of failure, because most of the time you would have a couple devices at the site for the redundancy, but the physical topology would look like this. So if I lost this link, I can still get back to those other links, right? Because I've still have multiple paths to reach. Or if I lose this link, I can still get to every other link. So this gives us the most redundancy, but it also comes at a much higher cost, because that means that I have to purchase circuits to each one of these sites. So for every site, they would need 4 other circuits to be able to have a full mesh topology. That gets expensive. If we just did this with a simple, hub and spoke topology, then you would need 4 circuits total, or 5 circuits total, right? But because we're doing a full mesh, you would end up with 20 something circuits, right? Or 20 circuits. So that would get very expensive. But you get a lot of redundancy out of it. And sometimes redundancy is the important fact. It's not about the money always. All right. So this is an example of a very basic network topology. We have a couple things going on in here, okay? And what this course is about understanding how data gets from A to B, right? Well, who's A and who's B? Well, let's say, for example, I'm going to do ABC. So we'll do A here, we'll do B here, and we'll do C there. Now, in our example, we did use an icon that I don't know if I explained earlier. We've got this as a hub, okay? And so the icon's different from the hub I showed you. I apologize about that. The point of this, though, is to understand like how A would get to B versus to C and so on. So if I want to send traffic from A to B, it might be as simple as sending a frame directly to B, right? But it might be as complicated as I need to go to this router and then the router actually communicate back with B. So there's a lot of different components into this. But here's one of the things I wanted to explain with this slide, which is each city here, you see Austin, Chicago, and New York. Each of them have a LAN. A LAN is a local area network, okay? And it's devices that have similar connection properties that are inside the corporate facilities, inside the office, and things like that. In other words, they're not exterior facing to the public world. So think about all your work PCs and your APs and your printers and scanners and servers and all that kind of stuff. All of those are LAN devices, okay? And we interconnect on LANs with switches, and the type of traffic we send on LANs operates at layer 2. We'll learn what that is as we go forward, but just know that that's there, okay? Now, how do we get from Austin to New York, for example? Well, we're going to have to use a WAN in this topology. WANs are used to interconnect LANs. So whenever a company grows to a larger size and they have multiple locations, they get interconnected by a wide area network. Now, LANs are typically managed by an IT team that's there at the company. WANs are typically managed by a service provider, okay? And the services are typically leased from a service provider. So we would pay another company to give us the circuit that gets us from Austin to Chicago. We're not going to buy land and trench fiber, for example, from Austin to Chicago. Wouldn't make any sense. But we could piggyback on a service provider who's already done that, right? Who has either packets to give us from their existing fiber lines, or maybe even has fiber circuits in place that we could get a pair from. We'll talk more about that. But anyway, those services are leased from a third party, okay? So routers are used to interconnect WANs, and they're also used to connect us to the public internet, which we'll talk about as we go forward. But in our example here, to get from Austin to New York, we got to go through Chicago. And notice this line here, this jagged line. That again we used to use example is serial connection. That's an older WAN technology that we used. Okay, nowadays we could use broadband Ethernet, we could use fiber, we could use Metro Ethernet, we could use MPLS, all that kind of good stuff, which we'll get into a little bit later. But this is just really signifying that we have a WAN here that's in Chicago's kind of our hub. Okay. So the traffic will get to New York. And by the way, this process up here, this WANs, is where we use layer 3 technology, which will make more sense after we go over the layers, right? And then over here at New York, for some reason we had that hub in there. I'm not sure, don't even remember why I freaking put it there. But you'll learn that hubs are a layer 1 device. There's still layer 2 going on here as well, but this is a kind of a dumb device that repeats everything. Anyway, network topologies. We have LANs, which are owned by the company and managed by that organization typically. They might be outsourced nowadays. There's a lot of companies that are involved in outsourcing services for LANs, but a lot of bigger companies that have an IT staff, they support all the interior stuff that's not facing the public internet, right? Or the connections that connect the offices between cities or sites or things like that, right? That's all WANs, and that's typically leased from service providers. So, as I've already mentioned, there's many types of networks. There is LANs, a local area access network, and that's used to describe a much, an interior network, like we said. There's MANs, which are metropolitan area networks. They're used to describe, networks that are around a metropolitan area. Typically, we work with service providers for those, but it could be still owned if you're a large enough company to have a MAN. Then we have WANs that are leased from third-party providers, and then you have the wireless variants of these, right? You have a wireless LAN, you have a wireless MAN, you have a wireless WAN, and that just means that we're using RF as the transport between those, locations. Well, how do you have a wireless WAN and go over wide areas? Well, there's all different types of wide area wireless services. We have things like microwave. We have things like satellite, right? So typically, if there's a wired component of networking, there is nowadays definitely a wireless component of it that is available as well. each of them has their advantages and disadvantages, and we'll be talking about wireless extensively in this class. All right, so LANs, again, it's one of the focuses of the class, okay? So, before you can go out and connect the world, you need to understand how things are connected in your local office. If you're a big enough company to have a stack of switches like this, then or several stacks of switches like this, then your company definitely has some good networking going on, because these are some of the newer 9000 series switches that are out there. These are gigabit, but there's 10 gig and 100 gig uplinks and stuff like that. And we'll talk about that as we go forward. But LANs connect devices at layer 2. Okay, so the way I want you to think of things, and I've already mentioned the layers, we're going to go over that in the next lesson, but LANs connect devices at layer 2. And all different types of devices, not just laptops and desktops, but also printers and scanners, and nowadays even things like badge readers and IP cameras, IP phones, okay, digital media players, all different types of, even TVs, smart TVs have basically they're a computer too. So those would all be devices that are connected on LANs, and switches help us connect all those devices through a LAN at layer 2. Okay, if you've heard of something called a layer 3 switch, right now it does not exist in this program. We'll talk about it existing later on, but right now I want you to think of LANs as just layer 2. Okay, all right, so WANs. WANs are wide area networks. They interconnect LANs, and they can also scale, greatly in size. We're leasing these from third-party providers again, okay? And this is how we can interconnect offices, and how companies can have offices that are doing business all over the world, okay, and still be interconnected. Now, there's different types of WAN technology out there, but WANs are typically leased from a third-party provider, okay? Here's the thing though, a lot of people, whenever they're starting out in networking, will confuse a WAN with the public internet, okay? Don't do that. The public internet and a WAN are two very different things, okay? Whenever I am connecting my offices over a WAN, that is still a network that is under my administrative control, okay? So let's say I've got 3 locations, okay? So let's say headquarters is over here in Austin, and I've got a Chicago, and I've got a Denver, okay? And I want to connect these offices. Well, I would lease the circuit from a service provider, okay? And this could be like Spectrum, Verizon, Global Crossing, any number of freaking service providers out there, right? Charter, you name it, CenturyLink. So, and I choose the WAN that makes sense for my businesses, how many users I'm going to have, what my bandwidth requirements are, what my uptime requirements are, all those characteristics we talked about, okay? And we subscribe to those services. But at the end of the day, I am responsible as the administrator for all of this, okay? So I am managing all this. That's a WAN, all right? The internet is a little bit different. The public internet, I do not manage. It's untrusted, okay? These sites, I'm leasing private links that are dedicated for my use. Whether it's packet switch or circuit switch, doesn't freaking matter. Those are my links that I'm leasing, and they belong to me, and I'm using them between my locations. However, once I get over here to the public internet, that is all the devices that live in the public realm, okay? Think of it as walking outside of your office to the rest of the world. Within the office, that's under your administrative control, but you don't have any control really over the rest of the world, right? So same thing with technology. I can control what's on my LANs and what's on my WANs, and I will even be managing how packets move throughout all that. But once they get to the public internet, I have no administrative control whatsoever, okay? let's see here. All right, so network components. Whenever people think of networking, whenever I used to teach these fundamental classes, this is 7 years ago now, whenever I started, 8 years now that I've been teaching. Full time, that is. I've been teaching for around 10 years, 8 years full time. But whenever I started teaching, I started with like the CCNA, okay, and all the CCNA specialization courses and everything. And I noticed during the CCNT and the CCNA that whenever you talked about networks, everybody immediately started thinking about switches and routers. And those are critical network components. That's a device that's used to connect LANs and a device that's used to connect WANs and interconnect LANs and all that kind of stuff. But there is a lot more going on with networking than people realize, okay? And I need you to start thinking about the details, okay, in this program, because you need to, we need to understand all the details for computer networking and how data moves throughout the network. So what are some of the other components you might not have thought of? Well, there's the end devices, okay? So that could be computers, but it could also be any of my iDevices, iPhone, iPad, tablets, e-readers, whatever it is. We'll just call these, user devices. That's actually a better name nowadays. It used to be that we built networks to connect computers, but nowadays some of the most common devices are people's smartphones, right, on networks, and they use a ton of bandwidth. Yeah. We've got the user devices, which could be anything from the smart devices, computers, tablets, you name it. Then we've got routers, okay, and of course we'll go into very good detail about what routers are. You're going to learn to configure them, all that kind of fun stuff, and the same with switches, which I said most people think about. But what about the network interfaces? The network adapters that are in these devices, whether it's a LAN or a wireless LAN network interface card. The computers and devices all need to have a network interface card to be able to communicate on that particular type of network. For example, you don't see Ethernet cables on smartphones and iPads, and there's rumors even the new iMac's not even going to have a built-in Ethernet port. Who knows if that's true or not, but everything's kind of, a lot of things are definitely losing that traditional type of connection. And especially smartphones and tablets wouldn't make any sense to have an Ethernet cable on it for 99.99959 right, percentage of the things that are out there. It wouldn't make any sense to have an Ethernet cable on those type of devices. But also, speaking of cables, the cables themselves, those are critical network components, okay, for the wired devices. And understanding the different types of cabling is a big part, of all this. What about the end connections on the cables? Okay, there's multiple building standards for data cabling, by the way. So you got to understand which cabling types we're using. What about the panels that interconnect the cables? What about the way we do our pins, our pin out on the cables? Is it a straight through cable? Is it a crossover cable? Is it a fiber cable? Right? Is it a console cable? All that kind of stuff we got to talk about. And then there's a whole world of RF on this. And then underneath it all, there's software, okay? Or running over it all is software, okay? So you have all these different other components that are out there that are responsible for networks happening. And by the way, guess what's on a router and switch? Network interfaces, right? That's how they connect to the network too. That's how they interconnect networks, is through network interfaces. They have a lot of network interfaces. And they also run software. So one of the things that I want you to do, if you're not already doing, is understand that there's a difference between hardware and software, okay? Especially nowadays. Whenever I started with networking, we had all these boxes coming in that was like, oh, that's a router, oh, that's a firewall, oh, that's a switch. Cisco quit making a quote-unquote router a long time ago. They are not now all integrated services devices, which means they can do routing, they can do switching, they can do firewalling, they can do all different types of things depending on the software running on them. Just like I can run a router on my laptop if I want to, and a real router that runs routing protocols with the right software. So I just want you to understand early on there's a difference between hardware and software, and there's a lot of different components that we need to get familiar with that make up an internetwork. Okay.